You know, this question is very important question. As known, the fiber in our rebar is in one direction. The effect of having the fiber in one direction give us a linear up to failure stress strain curve. However, if we will include another fiber orientation, like I saw some patents dealing with this kind of orientations, you will have a plateau is similar to the yielding plateau of the steel bar. This one is a very good technology, and you know, we are working on this in our labs in China. We are working on a patent like this, and we are trying, you know, some different fiber orientations, and we will get, you know, a very good result, you know, on this very soon. This research topic will give us a space to change some of the code equations, you know, not here in Canada, but or over the world, you know. We need to assume a reasonable value for the depths. You will have to go with trial and error. So it will take a lot of time from you. So what I did based on our projects, I modified, you know, the equation in the CG curve. We have a curve called the CG curve. This curve is related to the European codes, and this curve giving this equation, you know, but without modifications, in order to estimate the depths. They are using this equation mainly to estimate the depths of any structural element under flexure loads. So what I did, I modified this one based on the design cases I had in our company. So I have a lot of design cases. I did a slight modification for this equation in order to get a reasonable value for the footing depths. By using this equation, you will get an approximate value, and sometimes it will be an exact value. So you can put it on a side and estimate, you know, the footing depth from this equation, and keep it on a side. No need to show it for someone. You can, by using this equation, it will be very helpful for you to get an approximate or an exact, in some cases, estimation for the flexural depths. So I derived this one based on many design cases I had. But, you know, we need a lot of investigations in order to refine this model. You know, I can't say this model is final or something like this. But, you know, we are still devoting for studying many structural elements, you know, here in Canada with many universities interesting in this kind of free bar. So this kind of this equation, you know, should be we should have an equation like this, you know, after a lot of investigations. But now we don't have any equation to estimate the depth. So what can we do? We can use this equation in order to have an exact value. Let us say at this step you will say I will try d equals 450. So you will try 450, and after a while you will do another trial until you get an approximate value or an exact value, you know. But you can use this equation directly in order to get a reasonable value, as I explained to you. The thickness of this kind of footing is commonly governed by the two-way bunching shear. Okay. But according to the Canadian Code 823, and they, you know, they recommend also to check one-way bunching shear. But for 100%, if you have two-way bunching shear in a safe mode, you will have one-way shear in a safe mode. But it is not critical, as I told you, it is not critical to check it. The most critical one, and which govern the design, is two-way bunching shear, in order to avoid the two-way bunching shear in this footing, in flat slabs or other structure like this, which have the contact between a column or a slab, between a column or a footing, you need to check this kind of failure in order to avoid it, you know,
Yeah.
because having unsafe two-way bunching shear will cause a very big problem, you know, in the site after casting this footing, like 1 to 3 months, you will have a problem, you know.